All right. So today I've been tasked with the topic of dynamics of EV adoption, and I will try to be covering the basics and on on the details of the EV drivetrain with respect to the other drivetrains that are available, that has been covered earlier by the eminent speakers who joined the call earlier today. So I will mostly be discussing on challenges, total cost of ownership, and likely issues, and some policy initiatives during this which drives price parity. So on the basics of EV adoption, we have seen the benefits of adoption as well as the major challenges like the high upfront cost, the range anxiety, and operational challenges as well as technology risks associated with EVs. So just looking at the driving factor, there is a Deloitte study shows that around half of the reasons for people buying electric vehicles have been environmental reasons, which is resulting in lower emissions. And then another third is actually turning to EVs because of the lower operating costs. And another driving factor that we can see is that, there has been a lockdown effect on global emissions. There has been a reduction in global emissions. Since the COVID pandemic lockdown, and this a major cause of it is surface transport. So, because of the lockdown, we have seen a reduction, and that will only be even more prominent with a switch to electric vehicles. So we have you have already looked at the complexity of a gasoline or an IC powered drivetrain versus a electric powertrain. And the less complex it is, the less cost of maintenance, and other risks are also reduced. So what are some of the challenges of EV adoption in India? So some major challenges have been bucketed into technical, economic, infrastructural, and other social challenges. So the technical challenges being the limited range, which is range anxiety, and again related to that, the limited battery life, and also a lack of confidence, because there is no there aren't any reference point for the performance or the track record of any EV as of now. And economic challenges like high initial cost, the battery replacement cost, and also the limited options for vehicular finance, because EVs, again, being a nascent technology, the financing options are also limited because the risks are high for financing. And on infrastructural challenges, again, there is the availability of charging stations, which is which gives you the range anxiety, and again, since it is a nascent technology, the lack of repair and maintenance and import dependence, majorly for battery manufacturing and other raw materials. Then there are social challenges like lack of awareness and limited understanding. So when we look at EVs versus ICE vehicles, a major limitation you could see about EVs is the energy density. So when compared to a petrol or a diesel powered vehicle, the energy density as of now is quite less, which makes it much more costlier and than an ICE vehicle. And this is the kind of vision that we have for electric vehicles to reach up to gasoline's energy density, and you have discussed that earlier in earlier sessions. So just to give a perspective on that, and also to looking at the energy utilization of the consumption of energy of electric vehicles, looking at an electric bus. we see that when you're looking at a route level total cost of ownership of an electric bus, it is mainly dependent upon the fuel efficiency and the route length and other route characteristics of a particular route. So this, I mean, a best case a best case fuel efficiency can be affected by these various factors like driver behavior, road quality, the loading, passenger loading, speed, topography, the gradient in a particular city like flyovers or hilly areas, climate, temperature, and you can see that the speed, topography, and climate are the high impact variables on energy consumption of an electric vehicle. So, and ours being a tropical country, climate plays a huge role. So now we have seen some of the limitations and challenges. Now let's come to the economic side of owning an electric vehicle. So on owning an electric vehicle, the key components is the technology, the operation, and other external factors, the ones that we mentioned a little earlier, which affect the performance indicators. And another larger ambit under which the total cost of ownership or economic feasibility of owning and operating an electric vehicle lies in the selection of business models. So right now with fleet ownership of electric vehicles, and especially when electric buses are part of the conversation, we come across terms such as outright purchase, leasing model, subscription, aggregation models. So all these models have a bearing on the total cost of ownership of owning and operating an electric vehicle. So innovative business models and financing instruments are key to reducing the risks, the economic risks and technical risks of owning an electric vehicle. So the major components like technology, operations, and other external factors like we discussed earlier, which have a bearing on the performance indicators. So when one does a total cost of ownership analysis, we can identify which are some of the high impact and low impact variables that are affecting your total cost of ownership of owning and operating the vehicle, and that can guide the procurement, deployment, and other policy decisions as well. So some of the emerging business models for electric vehicles that we are seeing right now is there is the leasing model, which has been adopted by EESL on electric cars, where there are companies which play an intermediary role between the OEMs and the fleet operators by providing EVs on lease to fleet operators. So essentially, if the fleet operator is a public agency, and that the upfront cost of buying an electric vehicle is being borne by the company which plays the intermediary role. And in India's case, here we have seen EESL playing that role. Again, another model that we have seen is the battery leasing model. So in the case of electric vehicles, almost 40 to 50% of the capital cost of an electric vehicle, especially when we're talking about buses, is the battery. So considering that, removing or disaggregating batteries from the whole equation reduces the cost by around 40 to 60%, right? So there are customers who can buy the vehicles without the battery, and there are battery lessors who will provide the batteries on a leasing model. So this will allow the buyers to finance electric vehicles at more competing terms or in parity to ICE. So this model has been tried in Shenzhen, and it has also been tried by the OEM Proterra in USA. So this model has been mostly used where at times when the technology is just stabilizing. So in Shenzhen, this was the earlier model which was adopted when the rampant scale up of electric buses was happening, and then it was brought back to the other to the regular GCC model. But again, this gives operators this removes the risk of technology from operators. Especially here, even in India, a lot of public STUs are, in case of buses, a lot of public STUs are slightly hesitant when taking the whole plunge into electric vehicles, because the battery technology has been changing, rampantly over the past few years. So initially, we used to see, one technology, and now there are other technologies that have taken its place. So this model reduces that risk. And then the other model, or another model that has been used in case of even other vehicles and other segments, not only just EVs, is the aggregation model. So aggregation, it helps in better utilization of the asset, and also it helps reduce the costs by bringing in economies of scale. So aggregators who can pool risks and achieve better credit control. So essentially, when you're bringing in, when you're aggregating the demand for electric vehicles or any material for that matter, it definitely reduces the risks, and it also reduces financing costs. So this has been put to use by CESL right now in case of buses and electric three-wheelers. So these business models, correlating the business models with total cost of ownership gives you a complete understanding as to what are some of the pain points of owning and operating an electric vehicle, and how can you reduce that pain point on a particular stakeholder by aggregating or disaggregating, uh, or reducing the risks by compartmentalizing the components of electric vehicle procurement. So here again, it is the Shenzhen model. So I'm not getting into the details of the Shenzhen model. And it is essentially the battery leasing model, where there is a financial leasing company who bears the cost of the vehicle, without battery. And then there is the OEM who will be leasing the batteries to the bus company. And there are the charging facilities which is owned by the power company, and finally the bus company operates the buses. So this essentially brings down the high capital cost on a particular stakeholder, and it is balanced out among the different stakeholders. And again, the credit worthiness of the companies, of the holding stakeholders is enhanced with the introduction of the financing leasing company, the electric power company, because again, which can be translated in India, because even in India, STUs are not considered credit worthy. So essentially, bringing in other stakeholders who bring that credit worthiness to the table will definitely reduce financing costs and reduce the entire cost of the procurement process itself. So here I would like to introduce you to the total cost of ownership model that we at WRA has developed. So this is essentially the model where we will be providing inputs on CAPEX, OPEX, and other vehicle usage details, and the TCO model will give you the total cost of ownership per kilometer for a particular segment, which can be compared with various segments or even different models of the same segment. And sensitivity analysis of each cost component will provide you details as to what are some of the high impact and low impact factors. So this is the we have the TCO model will give you total cost of ownership per kilometer for all these segments as of now. So one can use the TCO sheet to compare between ICE and EV two-wheelers, between lithium ion and lead acid two-wheelers, and so on and so forth. So this is the total cost of ownership tool, and I've also shared the link to the tool over here. It would have been good if we can, if we could have, taken the tool out and did some exercises on it. But I think due to time constraints, we can probably skip over that. But essentially, if you go to this site, you can download the total cost of ownership. It is an Excel sheet. It is a very interactive, intuitive Excel sheet, which has, the first page is essentially giving you the whole instructions as to how to use this sheet and which all, where to add your inputs and which inputs cannot be touched. So all the instructions are provided in that Excel sheet, and we have developed the sheet for two-wheelers, three-wheelers, cars, buses, and freight vehicles as well. Freight, LCV, MCV, and HCVs. So the total cost of ownership, so these are the various vehicles, and the total cost of ownership will provide you the total cost of ownership over a period of 10 years, and provide you even year-wise total cost of ownership as well. So just to understand as to how how this helps, and what insights can you can you get from the total cost of ownership analysis. I'm just taking the case of three-wheelers right now. So on comparison of lithium ion battery e-rickshaws with lithium ion battery e-autos versus a CNG, petrol, and diesel three-wheelers, where the daily travel distance is 100 kilometers per day, we can see that e-rickshaws have a much lesser TCO than the other IC counterparts and even the e-auto counterpart. But e-autos at 100 kilometers a day, it is definitely achieving parity with even a CNG three-wheeler, and is much lesser than the diesel and petrol variants. And on applying FAME 2 subsidy, which was 37,000 for e-rickshaws and 66K for e-autos, the TCO per kilometer becomes even more economical. So this essentially gives you an idea as to what policy instruments, what is the quantum of subsidy, and what is the what are the daily operating parameters that needs to be tweaked, or that needs to be prioritized in order to optimize the total cost of ownership for electric vehicles in comparison to ICE vehicles. So here, one can play around with the numbers on the total cost of ownership. You can use different models of electric vehicles or ICE vehicles by changing the capital cost, the subsidies, the daily distance traveled, and even a lot of other inputs like the fuel cost, the maintenance, the financing costs, and other details, financing details as to how many years, what is the down payment, etc., etc. So we can also do some sensitivity analysis on the total cost of ownership. So here what we have done is we have seen that the average trip length per day for three-wheelers vary between 80 to 150 in urban areas. So we tried doing total cost of ownership at 50, 100, 150 and 200 kilometers a day. So what we see is that above 100 kilometers, TCO per kilometers is less than, for EVs is less than IC counterparts. But while if we go even less than 100 kilometers, if we go to 50 kilometers, this TCO goes to much higher levels than the IC counterparts. So essentially gives you an understanding as to what is that sweet range which makes the electric vehicles economical or in par with your IC counterparts. And another analysis that can be done with the total cost of ownership is that what is the year-wise total cost of ownership? What is the impact of holding period on the total cost of ownership of a EV in comparison to an IC vehicle? So here we can see that by the third year, e-autos without subsidies become cheaper than petrol and diesel variants, and for CNG variants it is fourth year itself. And with subsidies, we can see that the TCO per kilometer is actually less than IC variants from the year one itself. So here, this comparison gives you an idea as to what is that break-even period, or what is the holding, what is the effect of holding period on the total cost of ownership. So essentially, with increased vehicle utilization and increased period of ownership, essentially is offsetting that high capital cost, which is considered the biggest deterrent of electric vehicle ownership on the total cost of ownership. So the high impact factors are the distance traveled per day, the operational years, and of course the capital cost, which would include battery and charging. And some of the low impact factors are actually the maintenance cost per year, the fuel cost. We see that even a 100% hike in fuel cost does not have that huge an effect on the TCO that the distance traveled per day or operational years might be having. So I have also I also have slides on the cargo segment, as well as some interesting slides on e-buses. So Dhruv, can you give me a time check as to how much time I might have?
Yeah, so we have 15 more minutes to go, Aparna.
Yeah, thank you. So in that case, I will cover a few more of these calculations that we have done. So, what we have done with, again, electric three-wheeler segment is a look at the market potential for logistics and last mile delivery in the e-commerce sector. This is just giving you an idea of what is the potential till 2025, and here again we are seeing that for e3-wheelers, the TCO per kilometer is decreasing with increasing vehicle utilization and reduced capex. So from the previous discussion on three-wheelers and of passenger and cargo segment, what we see is that as the number of kilometers driven per day, or as the vehicle utilization per day increases, the total cost of ownership for an electric vehicle is reaching parity with your IC vehicle, or even becoming much lesser. So for electric vehicles, more than for personal travel, it is definitely, it is definitely economical for fleet level operations or operations where there is high daily utilization. Another, a look at electric buses and the TCO insights is providing you an idea as to how much, what is the subsidy quantum that is required to TCO per kilometer for electric buses. What is the kind of daily distance traveled that would bring down the total cost of ownership, and also the effect of the various business models. So we see that for FAME 1, there was no mandate on business models, but for FAME 2, the procurement model was mandated to be CCC models. Again, we have also seen the reduction in the subsidy, the subsidy amount from FAME 1 and FAME 2. So what is the effect of the reduction in subsidy amount on the cost of ownership? Again, what is the sensitivity analysis provides you an idea as to what is that break-even distance that will reduce your total cost of ownership. So what we see is that for electric buses, if the daily distance traveled is around 200 kilometers or more, there is a parity that electric buses achieve with the diesel buses. So here, what we have compared electric AC buses with a high-end diesel bus and a low-end diesel AC bus with a CNG AC bus. So all 12 meters. And we have also shared, I will also share the link of the total cost of ownership analysis on electric buses that is available on the website, which would give you much more insights on the sensitivity analysis. Again, the year-wise total cost of ownership gives you an idea as to what the holding period, the effect of holding period. And what we see is that for electric buses, even without subsidy at 200 kilometers, by around year 5, it does achieve that parity with diesel buses. So these changes can, you can play around with the inputs on the total cost of ownership sheet, and you can arrive at these insights as to how, what are the policy mechanism, what is the business model and financing mechanisms that can actually reduce the total cost of ownership for a particular vehicular segment. So again, for buses, some of the high impact variables are the distance traveled per year, what is the operational years or the holding period, and capital cost. And some of the low impact factors are the slow charger costs, the battery replacement cost, and energy costs, fuel costs. So this is the report on procurement of electric buses, which is available on the website, which will provide you much more much more insights on the sensitivity analysis on electric buses. These are some of the things that we discussed even earlier, on this presentation. So, the effect of there is a huge effect of climate, the temperature on energy consumption. So this provides you an understanding of temperature effects on e-cars, and also an effect on of speed on the drive range of electric car, and that too at different temperatures. So these are some of the anxieties associated with electric vehicles. So another area of huge anxiety is the lack of charging infrastructure or lack of public charging infrastructure, lack of policies or other incentives for home charging. So what we have done recently with Niti Aayog is that we have come up with a handbook on electric vehicle charging infrastructure implementation, which looks at what are the planning aspects that cities or local bodies need to be aware of while planning for charging infrastructure. What are the standards for EVSE, and also looking at the stakeholder framework for electric vehicle charging in cities in India. So this handbook is a very comprehensive attempt at planning for electric vehicle charging infrastructure in India. I would request all students to actually take a look at this guidelines, the handbook. And there are also, there is also the report on the Indian standards for electric vehicle charging infrastructure which was released in August 2021. And these coupled with other external factors like the raw material, the raw material availability across the world, and how that affects electric vehicle supply in our country, are some of the other associated anxieties or challenges with electric vehicle. These are some things that there are things that we can look at from the local level, but these are some of the larger national, global level challenges that are associated with electric vehicles. So, that requires innovation and diversification of technology, and also to look at the safety aspect of electric vehicle usage to reduce and eliminate the use of critical and toxic elements, to encourage circular economy, reuse, reduce, and recycling strategies for electric vehicle batteries, which will reduce the overall cost of cost of manufacturing and ownership, and reduce emissions, and also bring in the whole bring in the whole concept of circular economy in electric vehicles. The last segment is to look at policy initiatives which will drive that price parity, which is a critical pain point for electric vehicle scale up. This is actually a look at the Maharashtra EV policy and the demand incentives that were actually were there in the policy, and this is something that was done using the total cost of ownership. So in Maharashtra, we saw that the EV policy drives that 10% share of e-two-wheelers in the new registration of two-wheelers by 2025, along with which will be driven with a subsidy available for around 100,000 a lakh electric two-wheelers. So this is in addition to the FAME 2 incentives of 25,000 INR for electric two-wheelers, and there is also the scrappage incentive and the assured buyback and battery warranty incentive. So what we see is that there is definitely a reduction of around 55% for lithium-ion low-cost electric two-wheelers, and around 32% on high-cost electric two-wheelers with the policy incentives, coupled with the revised FAME 2 incentives in Maharashtra. So these are some things that can be done with the total cost of ownership to the evaluator, which will give you an idea as to what the impact of certain subsidies are on the actual owning of an electric vehicle. And we are also looking at it from in terms of, what is the impact of that on daily usage. So it actually gives us, like, an idea as to what the impact is for uh, 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 um, private usage as well as fleet usage. So I mean, 50 kilometer per day is a private for private usage, and if you're looking at 120 kilometers per day, this gap becomes even wider, and your total cost of ownership comes down to an even lesser rate. So again, we have done a similar analysis on the revised FAME 2 incentive for electric two-wheelers. So here at 100 kilometers per day, we can see that, I mean, with the revised FAME subsidy, the electric two-wheeler high-end vehicles are almost 1/3 of petrol two-wheeler total cost of ownership. Um, and again, similarly, on the economic viability of electric cars in Delhi, what we have seen is that for private usage, the total cost of ownership is at a higher rate than the diesel cars, and even with subsidy, it does not achieve that parity with an IC vehicle. But for commercial usage, when the total daily usage is around 195 kilometers or even more than that, we can see that the parity is achieved with subsidy. So this gives you an idea that a FAME to subsidy is a viable option, and I mean, makes it viable for electric vehicles or electric cars, especially only when there is commercial operation, or it is on a commercial application. So I would end here, and if there are any questions, I would definitely take it up.
Thank you, Ms. Aparna, for the wonderful session. It was pretty insightful to look at the research that WRI has done in the field of electric vehicle mobility, especially the TCO analysis, the TCO calculator. So, in the interest of time, what we will do is we will take the questions on the chat platform. So, because I believe there are still questions from the previous speaker which are going on in the chat box. So apparently there are a lot of questions that students will have. So what we will do is we will move on to the next session. But of course, all the students, whatever questions you have with regards to the topic that has been talked about, please post it on the chat platform, and Ms. Aparna would be around for some few more minutes with us. So all these questions she will be able to answer and take it up. So I thank you a lot, Ms. Aparna, for spending time with us today, for taking this session and sharing the knowledge and the information with us. And my request to you is to stay around for some time, so that if there are any questions or doubts which are addressed to you, so you can answer them on the platform itself.
Sure, Dhruv. Thank you. Thank you, the whole team, for this interaction. Thank you.
Thank
I
you
will
so
drop
much.
my email ID as well on the chat if anybody wants to interact with me. Yeah.
That will be great. Okay, so moving forward, we are moving to now the last technical session of the day, and